Welcome to CX1104 Linear Algebra for Computing. In this chapter 6.1.1, we continue on orthogonality and dot product, and today we would review vectors. A vector is an object that has both a magnitude and a direction, and the following ways are three equivalent ways to describe the vectors. Figure 3.1.1 shows a vector represented by a line segment. And in this line segment, it is represented as an arrow with an initial point and a terminal point. Hence, it has a magnitude. The magnitude is here, and where the arrow is pointing to, it is its direction. Therefore, if you have vectors being represented only by a magnitude and direction, you can therefore see that these four vectors having the same magnitude and the same direction are therefore equivalent vectors. There is another way to represent vectors, and here we use a boldface V to represent the vector, and we use capital A to represent the initial point and capital B to represent the final point, as in this figure, and with a little arrow on top of A and B to show that this vector goes from point A to point B. In summary, geometrically, we can picture a vector as a directed line segment whose length is the magnitude of the vector. The length is this length, with an arrow indicating the direction, and the direction is from the tail to its head. In the left plane of this slide, we discuss vectors without any reference to a coordinate system. But in this right side, we are going to use a coordinate system to describe a vector. Having a coordinate system is useful, as it will be easier for us to manipulate the coordinates of a vector rather than manipulating simply its magnitude and direction directly. When we express a vector in a coordinate system, we identify a vector v by a list of numbers, and we call this list of numbers the coordinates of the vector, or sometimes we also call it the components of the vector. We will discuss examples using the standard Cartesian coordinate system for the 2D plane. We have the x-axis, the horizontal axis, and the y-axis, the vertical axis. The tail of the vector v is at the origin, and the head of the vector is at v1, v2, where v1 is the component along the horizontal axis or the x-axis, and v2 is the component along the vertical axis. So where is v1 and v2? If we draw a vertical line dropping from v into the horizontal axis, this is v1. And if we project the vector v onto the vertical axis, this is v2. You may have noticed that we use the same notation to denote a point and a vector. Here is a point, and here is a vector. Actually, you can think of a point as being represented by a vector whose tail is fixed at the origin. You have to figure out from the context whether we are thinking of a vector as having its tail fixed at the origin, or if we are talking about a point. To continue with the example of a three-dimensional vector, we have x-axis, y-axis, and z-axis. The vector v has the origin has the tail at its origin, and at the head at v1, v2, v3, where v1 is representing the coordinate at the x-axis, v2 the coordinate as the y-axis and v3 as the z-axis. So it will be v1 value here, v2 value here, and v3 value here, representing this v vector in the 3D coordinate system.